Discover the process of making flat-screen TVs. Flat-screen TVs have become a ubiquitous part of modern life, with millions of households around the world enjoying high-quality entertainment and information on these devices. But how exactly are flat-screen TVs made? Let's explore the process of manufacturing flat-screen TVs. The first step in manufacturing a flat-screen TV is to create the glass substrate on which the television will be built. The glass is typically made from a combination of silicon, oxygen, and other materials, and is formed into a large sheet using a process called float glass manufacturing. The sheet is then cut into smaller pieces, each of which will become a television screen. Next, the glass substrate is coated with a layer of conductive material, typically indium tin oxide, (ITO), which will serve as the base for the television's display. The conductive layer is then coated with a layer of liquid crystal material, which will control the amount of light that passes through the screen. After the liquid crystal layer is applied, the glass substrate is heated and cooled to align the liquid crystal molecules and ensure that they are all facing the same direction. This process, known as rubbing, is critical to ensuring that the television displays a clear and consistent image. Once the liquid crystal layer is in place, the television is assembled, with additional layers of glass, backlighting, and other components added as needed. The backlighting is typically provided by an array of LEDs or other light sources, which are placed behind the liquid crystal layer to provide the necessary illumination for the display. After assembly, the television is tested to ensure that it meets quality standards and is functioning properly. This includes testing for color accuracy, brightness, and contrast, as well as ensuring that all components are working correctly. One of the challenges of manufacturing flat-screen TVs is ensuring that the process is environmentally responsible and sustainable. This includes reducing waste and minimizing the use of hazardous materials, as well as promoting recycling and proper disposal of old televisions. Another important aspect of the manufacturing process for flat-screen TVs is the design and engineering of the device. This involves the development of specialized software and hardware that can control the display, manage the flow of data, and enable users to interact with the device. The software and hardware components of a flat-screen TV are typically developed separately, with specialized teams working on each aspect of the device. The software components are designed to control the display, process incoming data, and provide a user-friendly interface for interacting with the device. The hardware components, such as the processor, memory, and graphics card, are designed to provide the necessary processing power and speed to support the software. In addition to software and hardware development, the manufacturing process for flat-screen TVs also involves quality control and testing. This includes testing for color accuracy, brightness, and contrast, as well as ensuring that the device is free from defects and meets all regulatory standards. To ensure the continued quality and performance of flat-screen TVs, ongoing research and development is necessary. This includes the development of new materials and technologies that can improve the efficiency and sustainability of the manufacturing process, as well as the development of new features and capabilities that can enhance the user experience. One area of ongoing research and development is the development of organic LED (OLED) technology, which uses organic materials to create light-emitting diodes. Old technology offers several advantages over traditional LED technology, including improved color accuracy, wider viewing angles, and thinner form factors. However, old technology is still in the early stages of development and is not yet widely available for commercial use. Another important aspect of the manufacturing process for flat-screen TVs is the supply chain and sourcing of materials. The components and materials used in flat-screen TVs come from a wide range of suppliers and manufacturers around the world. And ensuring that these materials are sourced responsibly and sustainably is critical to promoting a more environmentally and socially responsible industry. This involves working closely with suppliers to ensure that they are using responsible practices in their production processes, such as minimizing waste and reducing their carbon footprint. It also involves promoting ethical sourcing practices, such as ensuring that materials are not sourced from conflict zones or areas where labor practices are unsafe or exploitative. In addition to responsible sourcing practices, the manufacturing process for flat-screen TVs also involves minimizing waste and promoting recycling and reuse of materials. This includes developing closed-loop supply chains, where materials are recycled and reused in the production process, as well as promoting responsible disposal of old televisions and electronic devices. To ensure the continued sustainability and responsible practices in the manufacturing process for flat-screen TVs, ongoing collaboration and communication is necessary between manufacturers, suppliers, and other stakeholders. This includes working together to identify and address environmental and social challenges, as well as promoting transparency and accountability in the supply chain. In addition to sustainability and responsible sourcing practices, the manufacturing process for flat-screen TVs also involves ensuring the safety and well-being of workers throughout the supply chain. This includes promoting safe and healthy working conditions, providing fair wages and benefits, and respecting workers' rights to organize and form unions. To minimize the environmental impact of packaging, manufacturers are increasingly using eco-friendly materials and designing packaging that is recyclable or made from recycled materials. This includes using biodegradable materials, such as paper and cardboard, instead of plastics, and designing packaging that is more compact and efficient to reduce waste. In addition to responsible packaging, manufacturers are also working to minimize the carbon footprint of transportation. This includes optimizing shipping routes to reduce the distance traveled and using more fuel-efficient modes of transportation, such as rail and sea freight. Another area of ongoing research and development in the manufacturing process for flat-screen TVs is the development of more energy-efficient devices. This includes designing devices that use less power during operation, as well as developing more efficient manufacturing processes that minimize energy usage. To encourage the adoption of more energy-efficient devices, manufacturers are also working to develop new technologies and standards, such as Energy Star, that can help consumers identify the most energy-efficient devices. These technologies and standards are designed to promote energy efficiency and reduce the carbon footprint of electronic devices. Another important aspect of the manufacturing process for flat-screen TVs is the disposal and recycling of old devices. As technology evolves and new devices are introduced, the disposal of old devices is becoming an increasingly important environmental and social issue. To address this issue, manufacturers are working to promote responsible disposal and recycling of old devices. This includes developing programs to collect and recycle old devices, as well as promoting the use of certified recyclers who follow responsible recycling practices. In addition to responsible disposal and recycling, manufacturers are also working to design devices that are more durable and longer lasting, reducing the need for frequent replacement and disposal. This includes using more durable materials and components, as well as designing devices that are easier to repair and maintain. To encourage the adoption of more durable and longer-lasting devices, manufacturers are also exploring new business models, such as leasing and subscription services, that can promote responsible and sustainable use of electronic devices. Operating mechanism of smartphone. Smartphones have become an essential part of modern life, with billions of people around the world relying on these devices for communication, entertainment, and information. But how do these devices actually work? Let's explore the mechanism of operation of smartphones. At a basic level, smartphones operate through the use of hardware and software components that work together to perform various functions. The hardware components include the processor, memory, screen, and various sensors, while the software components include the operating system, apps, and user interface. When a user interacts with a smartphone, the device's sensors detect the input, such as a touch on the screen or a voice command, and send this information to the processor. The processor then interprets the input and performs the necessary calculations and operations to execute the desired function, such as opening an app or sending a message. The operating system plays a critical role in the operation of smartphones, providing the framework and infrastructure for running apps and managing hardware resources. The operating system also provides a user interface for interacting with the device, allowing users to navigate menus, access apps, and perform various functions. Apps are another important component of smartphone operation, providing users with a wide range of functionality and services, from social media and entertainment to productivity and communication. Apps are typically developed for specific operating systems, such as iOS or Android, and are designed to work seamlessly with the hardware and software components of the device. To ensure the continued operation and performance of smartphones, ongoing updates and maintenance are necessary. This includes regular updates to the operating system and apps, as well as regular maintenance and cleaning of the device to ensure that it is free from viruses and malware. One of the challenges of smartphone operation is the potential for security and privacy issues. As smartphones become increasingly connected to the internet and other devices, the risk of hacking, data breaches, and other security threats becomes more significant. To address these issues, manufacturers and developers are working to develop more secure and privacy-focused devices and software, as well as promoting responsible use and safe online practices. Another important aspect of smartphone operation is the role of connectivity and networking. Smartphones are designed to connect to a wide range of networks and devices, including cellular networks, Wi-Fi, Bluetooth, and other wireless technologies. When a smartphone is connected to a network or device, it can perform a wide range of functions, such as accessing the internet, sending and receiving messages, and streaming media. Smartphones can also communicate with other devices, such as smartwatches, fitness trackers, and other wearable devices, to provide a more integrated and seamless user experience. To ensure the continued connectivity and functionality of smartphones, ongoing research and development is necessary. This includes the development of new networking technologies, such as 5G, which can provide faster and more reliable connectivity and support for new applications and services. In addition to networking and connectivity, the operation of smartphones also involves the use of advanced sensors and technologies, such as GPS, accelerometers, and gyroscopes. These sensors allow smartphones to detect motion, orientation, and location, and provide users with a wide range of functionality and services. From navigation and fitness tracking to augmented reality and gaming. As smartphones become increasingly integrated into our daily lives, the potential for addiction and overuse becomes a growing concern. To address this issue, manufacturers and developers are working to develop features and tools that can help users manage their smartphone use, such as screen time limits, notifications and alerts, and other tools to promote responsible and healthy use. For example, AI-powered virtual assistants, such as Siri and Google Assistant, can understand and respond to natural language commands, providing users with a more intuitive and natural way to interact with their devices. AI and machine learning technologies can also be used to analyze user data and provide personalized recommendations and suggestions, such as recommendations for restaurants, movies, or music. To ensure the continued development and integration of AI and machine learning technologies in smartphones, ongoing research and development is necessary. This includes the development of new algorithms and models, as well as the collection and analysis of large amounts of data to train these models and improve their accuracy and performance. Another important aspect of smartphone operation is the role of the cloud. Cloud computing technologies allow smartphones to offload processing and storage to remote servers, providing users with more flexible and scalable computing resources. For example, cloud-based services, such as file storage and sharing services, allow users to access their files and data from anywhere, on any device. Cloud-based gaming services, such as Google Stadia and Microsoft's Cloud, allow users to play high-quality games on their smartphones without the need for expensive hardware. To ensure the continued development and integration of cloud technologies in smartphones, ongoing research and development is necessary. This includes the development of new cloud-based services and applications, as well as the optimization of cloud infrastructure to improve performance and reduce costs. As smartphones continue to evolve and integrate with other technologies, such as wearables, smart home devices, and the Internet of Things, the potential for new and innovative applications and services becomes more significant. To take advantage of these opportunities, ongoing collaboration and communication is necessary between manufacturers, developers, and other stakeholders, as well as a commitment to responsible and sustainable practices. To address these issues, manufacturers and developers are integrating advanced security features and technologies into smartphones, such as biometric authentication, encryption, and secure boot. Biometric authentication, such as fingerprint and facial recognition, allows users to securely unlock their devices and access sensitive data. Encryption technologies, such as end-to-end encryption, ensure that data is protected from unauthorized access or interception. In addition to hardware and software security features, manufacturers and developers are also promoting responsible and transparent data practices. This includes providing users with clear and concise privacy policies, allowing users to control their data, and promoting responsible data sharing and usage practices. Another important aspect of smartphone operation is the role of accessibility. Smartphones are increasingly being designed to be more accessible to users with disabilities or special needs, such as those with visual or hearing impairments. To address these needs, manufacturers and developers are integrating features such as text-to-speech, closed captioning, and high-contrast displays into smartphones. These features allow users with disabilities to better navigate and interact with their devices, providing a more inclusive and accessible user experience. As smartphones continue to evolve and integrate with other technologies, such as artificial intelligence, cloud computing, and the Internet of Things, the potential for new security, privacy, and accessibility challenges becomes more significant. To address these issues, ongoing research and development is necessary, as well as ongoing collaboration and communication between manufacturers, developers, and other stakeholders. To address this issue, manufacturers are constantly developing new battery technologies and optimizing power management systems. For example, many smartphones now use lithium-ion batteries, which provide higher energy densities and longer lifetimes than previous battery technologies. Power management systems are also becoming more advanced, with features such as battery-saving modes and adaptive brightness adjustment, which help to extend battery life. Another important consideration in smartphone operation is the impact of these devices on the environment. The invention of the 3D printer. The process of inventing 3D printing technology, also known as additive manufacturing, has been a long and complex journey. The origins of this technology can be traced back to the 1980s, when various inventors began exploring the concept of building objects layer by layer. One of the pioneering figures in the development of 3D printing technology was Chuck Hull, who invented the first 3D printer in 1983. Hull's invention, which he called a stereolithography apparatus, SLA, used a laser to cure a liquid resin into a solid object, layer by layer. Over the following decades, a number of other inventors and companies began developing their own 3D printing technologies, using a range of materials and techniques. These included fused deposition modeling, FDM, which uses a heated nozzle to melt and extrude plastic, and selective laser sintering, SLS, which uses a laser to fuse powdered materials into solid objects. As 3D printing technology began to mature, its applications expanded beyond the realm of prototyping and into the production of finished products. Today, 3D printing is used in a wide range of industries, from aerospace and automotive to healthcare and consumer products. The potential applications of 3D printing technology are virtually limitless. In healthcare, for example, 3D printing is being used to create personalized medical implants and prosthetics, as well as to print living tissues and organs for transplantation. In architecture and construction, 3D printing is being used to create complex and intricate structures that would be difficult or impossible to build using traditional methods. Despite its many benefits, 3D printing technology also faces a number of challenges and limitations. One of the biggest challenges is the high cost of materials and equipment, which can make 3D printing prohibitively expensive for many individuals and organizations. Another challenge is the relatively slow speed of 3D printing, which can limit its use in high-volume production environments. As the technology continues to evolve and improve, however, it is likely that these challenges will be overcome. New materials and techniques are being developed to make 3D printing more affordable and versatile, while advances in software and automation are making the process faster and more efficient. In recent years, 3D printing technology has experienced a rapid expansion in popularity and accessibility. This has been driven in part by the increasing affordability of 3D printers and materials, as well as the growing number of open-source designs and online communities that allow individuals to share and collaborate on their 3D printing projects. The process of 3D printing begins with a digital model, which can be created using specialized software or obtained from online repositories. The digital model is then converted into a series of instructions that are sent to the 3D printer, which uses a range of materials and techniques to build the object layer by layer. One of the key advantages of 3D printing technology is its ability to create highly customized and intricate objects with a level of precision and in detail that would be difficult or impossible to achieve using traditional manufacturing methods. This makes 3D printing a valuable tool for prototyping and product development, as well as for creating personalized products and one-of-a-kind artworks. Another advantage of 3D printing technology is its potential to reduce waste and lower the environmental impact of manufacturing. By producing objects on demand, 3D printing can eliminate the need for large-scale production runs and the associated waste and energy consumption. Additionally, 3D printing can use a range of sustainable and eco-friendly materials, such as recycled plastics and biodegradable polymers. As 3D printing technology becomes more widely adopted and integrated into other industries and sectors, its potential applications continue to expand. In medicine, for example, 3D printing is being used to create customized implants and prosthetics, as well as to print living tissues and organs for research and transplantation. In space exploration, 3D printing is being used to create tools and equipment on demand, reducing the need for resupply missions and lowering the costs of space exploration. Despite its many advantages, 3D printing technology also faces a number of challenges and limitations. These include the need for specialized knowledge and skills, the limited range of materials and colors available, and the high cost of some types of printers and materials. As 3D printing technology continues to evolve and improve, new and innovative applications are emerging. One of the most promising areas of development is the use of 3D printing in the field of bioprinting, or the printing of living tissues and organs. Bioprinting involves the use of specialized 3D printers and bioinks, which are materials that contain living cells and other biological components. These materials are layered and shaped to create three-dimensional structures that can mimic the complex structure and function of natural tissues and organs. The potential applications of bioprinting are vast and far-reaching. In medicine, bioprinting has the potential to revolutionize organ transplantation, allowing for the creation of custom-made replacement organs that are less likely to be rejected by the recipient's immune system. Bioprinting is also being used to create models of diseases and to develop new drugs and therapies. In addition to its potential in medicine, bioprinting is also being explored for use in fields such as food production and environmental remediation. By printing plant and animal cells into edible and sustainable forms, bioprinting has the potential to revolutionize the way we produce and consume food. Similarly, by printing living organisms into environmental remediation materials, bioprinting has the potential to help clean up polluted environments and reduce the impact of industrial waste. Similarly, by printing living organisms into environmental remediation materials, bioprinting has the potential to help clean up polluted environments and reduce the impact of industrial waste. Despite its many benefits, bioprinting technology also faces a number of challenges and limitations. One of the biggest challenges is the need for advanced knowledge and expertise in both biology and engineering, which can limit the accessibility of the technology. Additionally, the materials and equipment used in bioprinting can be expensive and difficult to obtain. As bioprinting technology continues to develop, it is likely that these challenges will be addressed through ongoing research and collaboration. With the potential to transform a wide range of industries and fields, bioprinting represents a significant advance in the field of 3D printing technology. With the potential to improve and even save lives. As 3D printing technology continues to advance, new and innovative applications are emerging across a wide range of industries and fields. One promising area of development is the use of 3D printing in the construction industry, also known as 3D construction printing. 3D construction printing involves the use of large-scale 3D printers to create structural components and even entire buildings, layer by layer. This technology has the potential to revolutionize the way we design, build, and maintain structures. With benefits ranging from increased efficiency and speed to reduced waste and improved sustainability. One of the key advantages of 3D construction printing is its ability to create complex and intricate structures that would be difficult or impossible to build using traditional construction methods. One of the key advantages of 3D construction printing is its ability to create complex and intricate structures. Celestials in the solar system. The solar system is a fascinating and diverse collection of objects that orbit the Sun, ranging from small rocky planets to giant gas giants and icy bodies. Each of these objects has its own unique properties and characteristics, providing important insights into the formation and evolution of the solar system. The four inner planets of the solar system, Mercury, Venus, Earth, and Mars, are known as the terrestrial planets. These are small, rocky planets that are characterized by their solid surfaces and relatively thin atmospheres. Each of these planets has its own unique features, including Mercury's extreme temperature variations, Venus's thick atmosphere and runaway greenhouse effect, Earth's abundant water and diverse biosphere, and Mars's ancient riverbeds and potentially habitable subsurface environments. The four outer planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, are known as the gas giants. These are large, gaseous planets that are characterized by their thick atmospheres and lack of solid surfaces. Each of these planets has its own unique features, including Jupiter's Great Red Spot and extensive system of moons. Saturn's rings and large moon Titan, Uranus's tilted rotation axis and icy moons, and Neptune's active weather patterns and large moon Triton. Beyond the orbit of Neptune lies the Kuiper Belt, a region of the solar system that is home to a large number of small, icy bodies, including dwarf planets such as Pluto, Haumea, and Makemake. These objects are believed to be remnants from the early solar system, providing important clues about the conditions and processes that led to the formation of the solar system. In addition to the Kuiper Belt, the solar system is also home to a large number of comets and asteroids, which are small, rocky or icy bodies that orbit the Sun. These objects can provide important insights into the formation and evolution of the solar system, as well as potential hazards to Earth and other planets. Finally, the solar system is also home to a number of smaller objects, including moons, rings, and other debris. These objects are important for studying the dynamics of the solar system and the interactions between different objects. One of the most fascinating and mysterious objects in the solar system is the Sun itself. The Sun is a massive, luminous ball of gas that is the central object in the solar system. It provides the heat and light that sustain life on Earth and plays a crucial role in the dynamics of the solar system. One of the most important aspects of the Sun is its magnetic field. The Sun's magnetic field is responsible for a wide range of phenomena, including sunspots, solar flares, and coronal mass ejections. These phenomena can have significant effects on Earth's atmosphere and technology, making the study of the Sun's magnetic field an important area of research. Another important object in the solar system is the asteroid belt, a region of space between the orbits of Mars and Jupiter that is home to a large number of small, rocky bodies known as asteroids. The asteroids in the asteroid belt are believed to be remnants from the early solar system and can provide important insights into the processes of planetary formation and evolution. The solar system is also home to a number of moons, which are natural satellites that orbit around the planets. Some of the most interesting moons in the solar system include Jupiter's moon Europa, which is believed to have a subsurface ocean that could potentially support life, and Saturn's moon Titan, which has a thick atmosphere and lakes and seas of liquid methane and ethane. In addition to the planets, asteroids, and moons, the solar system is also home to a number of smaller objects, including dust and debris. This material can provide important insights into the formation and evolution of the solar system and the processes of planetary formation and evolution. Finally, the study of the solar system is important for understanding the potential for life beyond Earth. The discovery of potentially habitable environments, such as subsurface oceans on moons and the potential for liquid water on other planets, has sparked renewed interest in the search for life beyond our planet. One of the most fascinating and mysterious objects in the solar system is the Sun itself. The Sun is a massive, luminous ball of gas that is the central object in the solar system. It provides the heat and light that sustain life on Earth and plays a crucial role in the dynamics of the solar system. One of the most important aspects of the Sun is its magnetic field. The Sun's magnetic field is responsible for a wide range of phenomena, including sunspots, solar flares, and coronal mass ejections. These phenomena can have significant effects on Earth's atmosphere and technology, making the study of the Sun's magnetic field an important area of research. Another important object in the solar system is the asteroid belt, a region of space between the orbits of Mars and Jupiter that is home to a large number of small, rocky bodies known as asteroids. The asteroids in the asteroid belt are believed to be remnants from the early solar system and can provide important insights into the processes of planetary formation and evolution. The solar system is also home to a number of moons, which are natural satellites that orbit around the planets. Some of the most interesting moons in the solar system include Jupiter's moon Europa, which is believed to have a subsurface ocean that could potentially support life, and Saturn's moon Titan, which has a thick atmosphere and lakes and seas of liquid methane and ethane. In addition to the planets, asteroids, and moons, The solar system is also home to a number of smaller objects, including dust and debris. This material can provide important insights into the formation and evolution of the solar system and the processes of planetary formation and evolution. Finally, the study of the solar system is important for understanding the potential for life beyond Earth. The discovery of potentially habitable environments, such as subsurface oceans on moons and the potential for liquid water on other planets, has sparked renewed interest in the search for life beyond our planet. In conclusion, the solar system is a complex and diverse collection of objects that provides important insights into the formation and evolution of the universe. From the Sun to the asteroids, from the moons to the dust and debris, each object in the solar system has its own unique properties and characteristics that can deepen our understanding of the universe and our place within it. By studying the objects within the solar system, astronomers can gain insights into the processes of planetary formation and evolution, as well as the potential for life beyond Earth. Tiek Tuc Va Kong Trung Lap. The study of the solar system also includes the search for and study of comets. Comets are small, icy bodies that originate from the Kuiper Belt and Oort cloud, the farthest reaches of the solar system. They are characterized by their highly elliptical orbits and long tails of gas and dust that are produced as they approach the Sun. The study of comets can provide important insights into the early solar system and the processes of planetary formation and evolution. Another important area of study in the solar system is the study of planetary atmospheres. The atmospheres of the planets in the solar system vary greatly in composition and structure, providing important insights into the processes of atmospheric chemistry and physics. The study of planetary atmospheres can also provide important information about the potential for life beyond Earth. As the presence of certain gases, such as oxygen and methane, can indicate the presence of biological activity. Interaction between the universe and living things. The interaction between the universe and life on Earth is a fascinating and complex topic that encompasses a wide range of phenomena. From the effects of cosmic radiation on biological systems to the potential for life beyond our planet. One important aspect of the interaction between the universe and life on Earth is the study of astrobiology. Astrobiology is the study of the origin, evolution, and distribution of life in the universe, and involves the integration of knowledge from a wide range of scientific fields, including biology, chemistry, geology, and astronomy. By studying the conditions and processes that led to the emergence of life on Earth, as well as the potential for life on other planets and moons in our solar system and beyond, astrobiologists can gain insights into the nature and diversity of life in the universe. Another important aspect of the interaction between the universe and life on Earth is the study of cosmic radiation and its effects on biological systems. Cosmic radiation is a form of high-energy radiation that originates from sources outside the solar system, such as supernovae and black holes. This radiation can have significant effects on biological systems, including damage to DNA and other biological molecules. By studying the effects of cosmic radiation on biological systems, scientists can gain insights into the potential risks posed by cosmic radiation to astronauts and other biological systems in space. The study of exoplanets, or planets that orbit stars other than the Sun, is another important area of research in the interaction between the universe and life on Earth. The discovery of exoplanets has revolutionized our understanding of the potential for life beyond our planet, and has led to the discovery of a wide range of planets with unique properties and characteristics. By studying the properties and characteristics of exoplanets, including their atmospheres and potential for liquid water, scientists can gain insights into the potential for habitable environments beyond Earth. Finally, the interaction between the universe and life on Earth also includes the search for and study of extraterrestrial life. The search for extraterrestrial life involves a wide range of methods, including the search for biosignatures or signs of life in the atmospheres of other planets and moons, as well as the study of extremophiles, organisms that can survive in extreme environments on Earth. To gain insights into the potential for life in other environments. Another important aspect of the interaction between the universe and life on Earth is the study of the effects of space travel on human physiology. As humans venture further into space, they are exposed to a range of physical and psychological stressors that can have significant effects on their health and well-being. These stressors include microgravity, radiation exposure, and isolation and confinement. By studying the effects of these stressors on human physiology, scientists can gain insights into the potential risks and challenges posed by long-duration space travel, as well as the development of countermeasures to mitigate these risks. The interaction between the universe and life on Earth also includes the study of the evolution of life on Earth and the role that cosmic events may have played in this evolution. For example, the study of the impact of asteroids and comets on Earth's geology and biology suggests that these events may have played a significant role in the evolution of life on our planet. By studying the effects of cosmic events on Earth's history, scientists can gain insights into the potential for the evolution of life on other planets and moons in our solar system and beyond. Finally, the interaction between the universe and life on Earth also includes the study of the cultural and societal impacts of space exploration and discovery. The exploration of space has inspired a wide range of scientific, technological, and cultural advances, from the development of new materials and technologies to the promotion of international cooperation and understanding. By studying the societal and cultural impacts of space exploration and discovery, scientists can gain insights into the role that space exploration plays in shaping our understanding of the universe and our place within it. The interaction between the universe and life on Earth also includes the study of the potential for interstellar communication and the search for extraterrestrial intelligence, SETI. The search for extraterrestrial intelligence involves the use of radio telescopes and other instruments to search for signals from other civilizations in the universe. While no definitive evidence of extraterrestrial intelligence has yet been found, ongoing efforts to search for such signals provide important insights into the potential for life beyond our planet and the conditions necessary for the emergence of intelligent life. The interaction between the universe and life on Earth also includes the study of the potential for interstellar travel and the colonization of other planets and moons in our solar system and beyond. The development of new technologies and the exploration of potential habitats and resources on other planets and moons could provide important opportunities for the expansion of human civilization beyond Earth, as well as the development of new scientific and technological advances. Another important area of research in the interaction between the universe and life on Earth is the study of the role that life may play in the universe as a whole. The emergence of life on Earth and its subsequent evolution may be seen as part of a larger trend towards increasing complexity and organization in the universe, a trend that has been dubbed the era of complexity. By studying the role that life may play in this trend, scientists can gain insights into the potential for the emergence of intelligent life and the development of complex civilizations in the universe. Finally, the interaction between the universe and life on Earth includes the study of the ethical and philosophical implications of space exploration and discovery. As humans venture further into space and discover new environments and potentially habitable planets and moons, they are faced with new ethical and philosophical questions and challenges. By exploring these questions and challenges, scientists can gain insights into the potential impacts of space exploration and discovery on human society and the future of life in the universe. Another important area of study in the interaction between the universe and life on Earth is the impact of human activities on the environment of our planet and the potential for space-based solutions to address environmental issues. Human activities such as industrialization, deforestation, and climate change have significant impacts on the environment and the sustainability of life on Earth. The study of space-based solutions, such as space-based solar power and asteroid mining, provides insights into the potential for these technologies to address environmental issues and support sustainable development. The interaction between the universe and life on Earth also includes the study of the potential for space-based resources to support human activities and exploration beyond Earth. Space-based resources, such as water on the Moon and asteroids, could provide important opportunities for the development of space-based industries and the support of human activities beyond Earth. The study of these resources and the development of technologies to extract and utilize them provide important insights into the potential for sustainable human expansion into the solar system and beyond. Another important area of study in the interaction between the universe and life on Earth is the role of space exploration and discovery in inspiring and educating the public about science and technology. Relationships between celestial bodies. The study of celestial bodies and their relationships with each other has been a subject of fascination for astronomers and scientists for centuries. Let's explore the various relationships between celestial bodies and their impact on our understanding of the universe. Gravity and orbits. Gravity is one of the primary forces that govern the relationships between celestial bodies. It is the force that causes objects to be attracted to each other, and is responsible for the formation of planets, stars, and galaxies. The orbits of planets around stars are determined by the gravitational pull between the two bodies. The strength of this gravitational pull depends on the mass of the bodies and the distance between them. In addition, the gravitational pull between planets can cause interactions such as gravitational slingshotting, where a planet's gravity is used to accelerate a spacecraft. Tidal forces. Tidal forces are another important relationship between celestial bodies. These forces are caused by the gravitational pull of one body on another, and can cause the deformation or stretching of the body being pulled. Tidal forces are responsible for the formation of tides on Earth, and can also cause the disruption of moons and other celestial bodies in orbit around larger bodies. Binary and multiple star systems. Binary and multiple star systems are another interesting relationship between celestial bodies. These systems consist of two or more stars that orbit around a common center of mass. Binary and multiple star systems can provide valuable information about the formation and evolution of stars, and can also have an impact on the formation and evolution of planets in their respective systems. Interstellar travel. The relationships between celestial bodies also have implications for interstellar travel. The gravitational pull of planets, moons, and other objects can be used to assist spacecraft in their journey through the solar system and beyond. In addition, the study of celestial bodies has provided insights into the formation and evolution of the universe, and has helped us understand our place in the cosmos. Eclipses. Eclipses are a fascinating relationship between celestial bodies, where one object passes in front of another, obscuring its view. Solar eclipses occur when the moon passes in front of the sun, while lunar eclipses occur when the Earth passes between the sun and the moon. Eclipses provide valuable opportunities for scientific study, allowing researchers to observe the sun's corona or study the composition of the moon's surface. Comets and asteroids. Comets and asteroids are another important relationship between celestial bodies. These small bodies can have a significant impact on the formation and evolution of planets and other celestial bodies. Comets are icy bodies that originate in the outer solar system and have highly elliptical orbits that bring them close to the Sun. When they approach the Sun, they heat up and release gas and dust, creating a distinctive tail. Asteroids are rocky bodies that orbit the Sun, primarily in the asteroid belt between Mars and Jupiter. Some asteroids can pose a threat to Earth if they collide with our planet. Interactions between galaxies. Interactions between galaxies are another fascinating relationship between celestial bodies. Galaxies can collide and merge, leading to the formation of new stars and the disruption of existing ones. These interactions can also lead to the formation of black holes and the ejection of high-energy particles into space. Studies of these interactions can provide insights into the formation and evolution of galaxies and the universe as a whole. Gravitational waves. Gravitational waves are ripples in the fabric of spacetime that are produced by the movement of massive objects, such as black holes and neutron stars. These waves were first predicted by Albert Einstein's theory of general relativity, and were detected for the first time in 2015. The study of gravitational waves provides a new way of observing and understanding the relationships between celestial bodies, and has the potential to revolutionize our understanding of the universe. Planetary atmospheres. Planetary atmospheres are another important relationship between celestial bodies. The atmosphere of a planet is the layer of gases that surrounds it and is held in place by the planet's gravity. The composition and behavior of planetary atmospheres can have a significant impact on the climate and geology of the planet. For example, the presence of greenhouse gases in Earth's atmosphere helps to regulate its temperature and make the planet habitable. The study of planetary atmospheres provides important insights into the conditions necessary for life to exist on other planets. Interactions with space debris. Space debris, such as micrometeoroids and man-made debris, can pose a threat to spacecraft and satellites in orbit around Earth. The study of these interactions provides insights into the potential risks and protective measures necessary to mitigate them. In addition, the impact of space debris on planetary bodies can have significant implications for the formation and evolution of celestial bodies. Gravitational lensing. Gravitational lensing is a phenomenon where the gravity of a massive object, such as a galaxy or a black hole, bends the path of light from a more distant object. This can cause the distant object to appear distorted or magnified. The study of gravitational lensing provides important insights into the distribution of dark matter in the universe and the behavior of massive celestial bodies. Cosmic rays. Cosmic rays are high-energy particles that originate from outside the solar system. They are produced by a variety of sources, including supernovae explosions and black holes. The study of cosmic rays provides important insights into the behavior of massive celestial bodies and the structure of the universe. Magnetospheres.